Assalamualaikum. Alright, so in this video we'll look at the second method of volume, which is the application of integration, which is the washer method. So we should note the difference between this method and washer method is that in washer method we can have the hollow, meaning to say that we can have a hole in the middle of the solid generated. All right, so we can have that, but in this method we should not have any holes in the middle. All right, so we call that middle, we call it as hollow. All right, so we should note that the washer method should be put into two categories. All right, so the first one is the rotation about horizontal axis. All right, so horizontal line, and the next one is the rotation about vertical line. All right, so when we talk about the rotation about horizontal line, so it is parallel to x-axis. All right, kind of x-axis, so we should integrate later with respect to x. But if it is rotation about vertical line, because the vertical line is actually parallel to the y-axis, so we should integrate later with respect to y. Right, so now we have this, let's say we have these two function. All right, so suppose we want to rotate, we want to revolve about this y-axis. All right, we want to revolve about this y equal to a. Right, so that is the line. Y equal to a is something like this. All right, so we want to rotate about that, so we'll have something like this. Okay, when we rotate, so we'll have something like this, right? So this one should be something like this. Okay, so we'll get this kind of volume, and we note that there is hole in the middle. All right, this is the hole. Okay, so we should know that for this type of function, or for this type of graph, all right, so for this method we should find the outer radius and inner radius, because now we want to rotate about the horizontal line, which is parallel to x-axis. So we want to integrate later with respect to x. So our outer radius and also inner radius should be in term of x. All right, so which is a function of x. So outer radius, all right, so you look at this function, all right, so that is fx, because this function is outermost. All right, this is outer. Okay, we call this outer, and this is the inner. All right, when we compare it to the axis of rotation. All right, so outer radius is actually fx, so we'll take this fx as the outer, all right, fx, but we should subtract the one at the what do you call the x, the axis of rotation, which is, okay, a. So fx minus a is the outer radius. All right, so for the inner radius, all right, so if we can simplify, we try to simplify later. For the inner radius, we should note that this is the inner part, so this is actually gx. So gx, we should subtract the one with the what do we call this axis of rotation, which is a. All right, so next, when we want to calculate the volume, so the formula is given by pi integrate from c to d, because the region is actually from c to d. All right, this part. Okay, so actually we want to rotate this part only. All right, so we just want this part only. Okay, yes, we want to integrate this part only. All right, because we just want to get this green solid only. Okay, all right, this part. So we want to rotate from c to d. All right, so integrate from c to d of that rx square, which is the outer radius. All right, we know that we should have the outer radius square. All right, we outer radius, which is given by that, and we should subtract that inner radius, which is r small. All right, so square, we should square it. All right, so that is the inner radius. So with respect to x, so we should note that it is in term of x now. All right, so for the rotation about vertical line, all right, we have something like this. Right, suppose we have this. All right, so we want to rotate about x is equal to a, so this is the axis of rotation. All right, so it will be something like this. Right, we rotate it. All right, so it will be something like this. So we'll have something like this. All right, okay, so we have something like this. All right, so this is the rotation, right? This is the solid generated, and we should note that. All right, so the outer radius is, of course, this one is outer. All right, so this one I'll label it as outer. All right, so outer is given by fy, because we integrate with respect to y, yeah, because we rotate about the vertical line, which is parallel to the y-axis, so we should integrate with respect to y, so the function should be in terms of y, so x is equal to fy. All right, so fy is the outer radius. We should subtract the what we call x is equal to a, the axis of rotation, so Fy minus A. Right, so the inner radius is actually this one. All right, so this is the inner part, so which is given by Gy. We should subtract the axis, which is A. All right, so later when we want to calculate the volume, so the formula is given by pi integrate from C to dy, because it is from C to D. The solid is generated by revolving the area from C to D. All right, so Ry square, which is the, what do we call, the outer radius, all right, minus r small y square, which is the inner radius. We should integrate with respect to y now. All right, so after this we'll look at some examples regarding this washer method. Suppose we have this one. All right, suppose we have this one. So we want to find the volume generated using washer method. All right, when we revolve about x-axis. So we should note that x-axis is actually y is equal to 0. All right, so we should find the axis of rotation, which is actually here. All right, I'm gonna highlight this part. All right, so this is the axis of rotation. So we want to revolve the green region with about this x-axis. All right, y equal to 0. All right, so this is actually y equal to 0. So the first step is that we should identify whether it is dx or dy. Because it is rotated about horizontal line, so it should be dx. All right, so bear in mind that should be dx. So when we want to find it, volume, all right, it should start with pi integrate with respect to x. All right, so but before we could integrate, all right, we should find the what do we call it, the outer radius and inner radius. So rx, right, so rx, r, big R and small r. All right, so the outer radius in this part. All right, so when we see this region, so this is the outer part because it is far away from this axis of rotation. So that is given by, right, so this formula, which is we can write as y equal to 6 minus x. All right, so that is the upper part, outer part. So we should note that the Rx is actually 6 minus x, 6 minus x. All right, we should subtract with the axis of rotation, which is given by y equal to 0, so we should subtract with 0. We should show this calculation. Right, so for the inner radius, all right, so the inner radius is actually given by this. All right, so this is given by y equal to x square. All right, y equal to x square. So y equal to x square, so we want to use this x square. All right, x square minus the axis of rotation, which is 0. Right, so we simplify this one to be 6 minus x, this one to be x square. All right, so next we should note that we want to integrate. All right, if we should see this region, this is from 0 until, all right, should be on the x-axis because dx, right? So from 0 until 2, right? So given by this coordinates, so from 0 until 2, right? So in our formula, the outer radius minus the smaller radius, we should square both. All right, so now we should substitute with the value pi integrate from 0 until 2. All right, so the outer radius, all right, is actually 6 minus x square. The inner radius should be x square. We should square it. All right, dx. Before we can integrate this, we should simplify the expansion. All right, so 0 and 2, that one will be 36 minus 12x plus x square minus x to the power of 4 dx. So what we should do is to integrate like usual. All right, so I'm not going to show the full calculation, but you should know how to set up. All right, so this is important. All right, so this part is very important in this washer method. Okay, all right, so let's look at the second question. All right, so we want to use the washer method to find the volume where we revolve about the x is equal to 3. So we should find the line x is equal to 3 is actually the vertical line here. All right, so this is x is equal to 3. All right, so we want to rotate about this. All right, so bear in mind that we are now rotating with respect about the vertical line, where in our in the basic, for this one, we should know that when we rotate about vertical line, it should be dy. So in our mind, that later when we want to find the volume, it should be pi integrate dy. So when we want to find the radius, all right, outer radius, it should be in terms of y. So ry for outer radius and for inner radius. So look at your region, all right, which part is far away from this axis of rotation? Of course, this part, right? So this is outer, which is given by, all right, so we should write in terms of y, all right? So we should modify this one to be x is equal to 2y plus 11, all right? So x is equal to 2y plus 11. We should note that it should be in terms of y, not in x, all right? So we should minus, all right, subtract the x is equal to 3 because it is the axis of rotation. All right, so that is for the outer part. So this is the inner radius, all right? So the inner radius, which is given by this part here. So we should write it as, okay, that one is given by y squared plus 3. So y squared plus 3. And we should subtract with the axis of rotation, which is x is equal to 3. All right, so simplifying this, we will get, all right, so let's see, 2y plus 8. And this one should be y squared. All right, so when we want to find the volume, all right, so it should be, all right, ry square minus ry square, all right, outer radius minus inner radius. But from where to where, all right, so because now we integrate with respect to y, so the value on this should be on y-axis, so it should be the region. This one is from 0 until, right, so look at this point here, until 4, right, from 0 until 4. Why we should take the values on y-axis? Because it is integrating with respect to y, so from 0 until 4. So we should fill up with 0 until 4. All right, so now we already have the ry, so we just insert into this formula. All right, so that one should be 2y plus 8 square minus y square dy. All right, so now we'll have pi integrate from 0 until 4. That one should be 4y squared. That one should be 4 multiplied by 8, right? I guess 32. All right, 32y and plus 64, all right, minus y to the power of 4 dy. And we should find the value for this integration, right? So I'm not going to show everything here. All right, so that's how you do this washer method for this one. All right, what about this one? Now we want to find the washer method. All right, revolve about x is equal to 2. Find the line x is equal to 2. It is a vertical line here, right? So x is equal to 2 is the axis of rotation, so meaning to say that we want to rotate this way. All right, so now, so we know that if we want to rotate about vertical line, so the volume letter should be the pi integrate with respect to y. All right, so we should write everything in terms of y here, ry and ry here. All right, so now the outer radius should be the one that is further from the, all right, from the axis of rotation, of course, this one. So x is equal to negative y. So this one is the outer radius, negative y minus, or sometimes, or you can take this, because the axis of rotation at the right side of this, what do we call, region. So we should have this axis of rotation first. All right, so 2 is the axis, 2 minus the, what do we call, the outer radius here. All right, so the outer radius, the function is given by this and a negative y, so 2 minus negative y. So this is actually 2 plus y is the outer radius. So now we should find the inner radius. So the inner radius is this part here, so this is the inner radius. All right, so the inner radius, which is given by x is equal to 2 minus y squared, but we should write this one minus that one. All right, this one minus 2 is the axis of rotation minus this 2 minus y square. Okay, something like this. So we should simplify this, 2 minus 2 plus y square. This one should be y square. All right, so now for the volume, all right, so the big R square, we should minus with the small r, should square it. All right, so the value on this integral should be on the y-axis because with respect to y, so it should be from 0, all right, this one from 0 until 2, right? So from 0 until 2. Now we want to substitute that one, all right, with inside the formula, all right. So that one should be 2 plus y square minus y square square dy. So we will have something like pi integrate from 0 until 2 of that 4 plus 4y plus y square minus y to the power of 4 dy. And we perform the integration and we get the value for this volume generated using the washer method. The next one, we want to find the washer method, all right, the volume using washer method when we revolve about y equal to -1. So we should find the line y equal to -1. So y equal to -1 is this horizontal line here, right? So y equal to -1. This is the axis of rotation, meaning to say that we want to rotate the green region with about this line. So what do we call? We should note that when we rotate about the horizontal line, all right, so the volume letter should be integrate with respect to x. So now we want to find the outer radius and inner radius in terms of x, all right, so rx here, all right. So the outer radius, all right, so because the line, the axis of rotation is there, so this is the outer part, all right, so this is the outer radius. So the outer radius is given by 4, so 4 minus the axis of rotation is actually -1, all right, so 4 minus 1 you get 5. 4 minus -1 will get 5. All right, so the inner radius, it should be this one because this is the nearest to the axis of rotation, all right. So the inner radius is given by y equal to x squared, so we want to use this x squared, right? We should subtract the minus the what do we call axis of rotation, which is -1, so we should have x squared plus 1. All right, so now we want to substitute inside the formula, so the formula should be given in terms of x, all right, so rx squared minus rx squared, right. So the value on this integral should be on x-axis because we are now integrating with respect to x. So on the x-axis for this one, so this is the value which is 0 and this is actually given by 2. So from 0 until 2, from 0 until 2. Now we substitute inside the formula, all right, so we'll have something like pi integrate from 0 until 2 of that 5 square minus that x square plus 1 square dx. Right now we will have something like integrate pi integrate from 0 until 225 minus, all right, so that one should be inside the bracket first, all right, x to the power of 4 plus 2x square plus 1 dx, right? So simplifying that, we'll have something like 0 until 225 minus x to the power of 4 minus 2x square minus 1 dx, right? So now you'll find the volume by integrating this using a definite integral. All right, so now I'm going to show full example, full solution for this one. All right, so next one, number 5. All right, suppose we have this region. Now we want to find the volume when it is revolve about y-axis using washer method. So we should note that when we have the word y-axis, it is actually x is equal to 0. So it is a vertical line here, all right? So this is our axis of rotation, x is equal to 0. All right, so now we should note that later when we want to find the volume, we should use the formula pi integrate with respect to y because it is a vertical line, a vertical line here, right? So dy. So we should find the outer radius in terms of y, right? So in terms of y, because later we want to integrate with respect to y. So the outer radius, all right, so looking at this is the axis of rotation. Which one, this one or that one, is the outer? Of course the one which is far away from the axis of rotation, of course this one, right? All right, so this is actually given by y equal to x squared. But should we write x squared here? No, we should write everything in terms of y, so we should modify this one a little bit, right? So this one should be x is equal to square root of y. So this one is actually square root of y. We should subtract the axis of rotation, which is 0. So this is actually square root of y. All right. For the inner radius, all right. So for the inner radius is of course given by this function, all right. So it is actually, right, y square equal to 8x. So x is actually equal to y square over 8. Right, so the function is actually y square over 8. All right, we should subtract with 0 because it is the axis of rotation. So we should have y square over 8 is the inner radius. So now we want to make use of the formula. So the formula should say that it is ry square minus the ry square, the outer radius square minus the inner radius square, and the value for this integral should be on y-axis, right? So on y-axis, the values here is 0, and this part here is actually given by 4. All right, so 4. So we have to write the 0 until 4 on that integral, from 0 until 4. All right, so now we have to substitute the formula for the ry, the outer radius and inner radius. We'll have something like square root of y square minus that y square over 8 square dy. So we have something like pi integrate from 0 until 4 of that y minus y to the power 4 over 64, right, dy, and we integrate like usual, and we get the final answer for this one, which is the volume using the Washer method for this green region here. All right, so that's it, as simple as that. All right, so what's important is that you have to find, you have to determine if it is integration with respect to x or respect to y. Now you have to find the outer radius and inner radius, all right, and then you have to substitute inside the formula for volume. All right, so let's look at the last example here. Right, now we want to use the Washer method, and when we want to revolve about y equal to 3. So y equal to 3 is actually this line. So this is y equal to 3. All right, so we should note that it is the integration with respect to x. Why? Because we are now revolving it about the horizontal line. All right, so now we should write first the volume should be in terms of x, so with respect to x. Then we know that the radius should be in terms of x for both the outer and inner radius. Right, so the outer radius, we should find the one which is further from the axis of rotation. Of course, this one, this is far away from the axis of rotation. All right, so which is given by x squared minus 2x. But we should note that the axis of rotation is upper part, all right, is higher than that function. So of course we should write this axis of rotation first. 3, right, is the axis of rotation. We should subtract the one at this outer part, which is x squared minus 2x, should be in the bracket. So simplifying this, we'll have something like 3 minus x squared plus 2x. All right, so that is the outer radius. For the inner radius, of course, we should look at this function here. All right, we should look at this function. All right, so this is the inner part. So we should have the axis of rotation 3 minus the inner part, which is given by x, right? So 3 minus x. So that is your inner radius. So we know that when we want to find the volume, the rx square minus with the rx square, which is outer radius, minus with the inner radius square. So we should note that the value on this integral should be in terms of x. So we should look at the x-axis. So the green region is bounded from 0 until this part, which is 3. So from 0 until 3 is the values on the integral, from 0 until 3. So now we substitute with the formula for rx and rx, which is the outer radius and inner radius. So we have something like 3x squared plus 2x squared minus the 3 minus x squared dx. All right, so this is quite challenging, but we can find it. All right, so don't worry, try to expand this one. All right, so we have something like, sorry, 0 until 3. All right, so suppose I want to, all right, so I want to expand this way, all right, which is the what do we call, minus that one should be 9 minus 6x plus x squared dx. All right, so you should expand this one. All right, and then you get the final answer after you have integrated. All right, that's it. So basically you have to determine whether it is, all right, rotation about x vertical line or horizontal line. So if it is about horizontal line, it should be dx. If it is about vertical line, it should be dy. Now you have to, after you determine that, you have to find the outer radius and inner radius. So with respect to x or y, just now that we've determined, and then we substitute inside the formula, which should have the pi in front. All right, so integrate from where to where and substitute back the outer radius squared minus the inner radius squared, and now integrate and get the final answer for the volume. Right, so that's it for the washer method. All right, so the last method that in the next video we'll see the shell methods. Thank you for watching.